Today's lesson is about what an ordered pair is. So every graph has two axes, the dependent and independent. The dependent is the y-axis running vertically, so up and down. The independent is the x-axis, and that's running horizontally on the graph, so left to right. Every point has an x-coordinate, and every point has a y-coordinate. And the way that we denote that, or the way that we write that down, is x comma y in brackets. On a straight line, there is always a relationship between each point. Understanding this relationship allows you to predict other points on the line. This relationship can then be turned into a formula, and that can express the line. So we're going to talk about different ways that we can express a relationship. So we're going to talk about a table. We're going to talk about an equation. We're going to talk about graphing. And we're going to find two other points on the line. First things first, let's talk about this table. So you're noticing 0, 0, 1, 5, 2, 10. What I want you to do is pause the video just for a moment and try to anticipate what these values are going to be, keeping in mind that we go 3, 4, and skip 5 and go to 6. So now that you've paused the video to anticipate, what I hope that you figured out is that this one's going to be 15, this one's going to be 20, and this one is going to be 30. Basically, what we're doing is we're taking the numbers, our independent, and we're multiplying that by 5 to get our dependent. That's just my short form, independent. If I were to write this as an ordered pair or coordinate point, and that's my short form for a coordinate point, I would write this one as 0, 0. This one I would write down as 1, 5. This one I would write down as 2, 10. This one I would write down as 3, 15. This one 4, 20. This one 6, 30. The next step of what we're going to do is we're going to write this as an equation. Now that is a little bit more of a tricky kind of thing to do, and in general I'm just gonna get you to plunk independent variables into equations to solve for the dependent. I won't get you to write an equation, but this one's a little bit easier. We kind of described it. You take the independent and you multiply it by 5 to get the dependent. So if we were wanting to find what our y point is, we would take our x point and we'd multiply it by 5. This right here is just our equation. So at this stage in the game, if you can't do this, don't worry about it. We'll get a little bit more practice later. What we need to do now is we need to graph the points. So I'm just going to make this a little bit smaller so I can see everything. I notice that the independent, so I know that my x variable can go up by ones. So 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. But if I do a scale of 1 on my y, on my dependent, we're going to run out of room really fast. So what I hope your takeaway from this is it doesn't have to be the same. As long as each of the distances on the x-axis are the same and each of the distances on the y-axis are the same, they don't have to be the same compared to each other. They just have to be same compared to itself. So then this is 5, 10, 15, 20, 25, 30, 35. Just like this one is negative 10. I'm just going to make it a little bit. Negative 20 and negative 30. I'm not going to put as many numbers down there. So when I'm graphing my points, I'm going to use different colors here. I'm gonna graph my 0, 0. So that's right smack dab in the middle. I'm going to plot my 1, 5. 1 and 5 right there. I'm going to plot my 2, 2, 10. So 2 and 10. And so on and so forth. I hope that you guys can see this trend here. Then I'm going to skip for 6. Or I'm going to skip 5, go to 6. But here's the thing that's so great about this. They'll all just lie on the same line. And I can anticipate right here that 5 is going to be 25. So let me just connect the dots here. Literally. So funny. Boom. We just graphed the points. That's all we have to do. Find 2 other points on the line. And I'm going to say by substituting into the equation. So we know the equation here, y equals 5x. So I'm going to find it. I'm just going to confirm 5 here. So say x equals 5. That means that y equals 5 times 5. That means that y equals 25. So if I was looking for a coordinate point to express this scenario, I would say that the coordinate point is 5, 25. Let's pick a different number. Let's pick a number that's way out there. What happens if we wanted to see what what y equals when x equals, say, 15? Well, all I would do is I would say, okay, if my x is 15, I'm going to substitute into the formula. So if x equals 15, y equals 5 times 15. That means that y equals 75. So if I were to write that as a coordinate point, I would say my x coordinate, 15, and my y coordinate, 75. So that's all we have up for this lesson here. So now what you can do is you can flip over the page and work on the worksheet.